Uh, we have guests from ITI Shirur Anantapal. Then we have Jayant Rega, Kirti Shinde, Komal Chaudhary, Kulab Pachri, Lalit Singh, Madhav Mayer, Madhu Chauhan, Mahesh Jadhav, Mahesh Bandhekar, Manoj Joshi, Namrata Nagpurkar, Praveen Manan. We have guests from research and training. Then we have Srikant Mahadik sir from Vidya Pratishthan, Umesh Pawarji, Vaibhav Lakshmi Wag, and my colleague Vivek Salwaru. Good. We will wait for another 4 5 minutes, or should we start? ठीक है. This is okay. Despite of having Holi today, you all have gathered to attend RoboDK webinar. So I, Sunil Chore, CMD of Simusoft Technology, welcome all faculty member in this technical festival. Robot now has covered every aspects of engineering, and its significance in Industry 4.0 is phenomenal. So whether it is automotive, healthcare, agriculture, manufacturing, everywhere now there is no option for robot. Now, being this complex and costly affair, everyone can't afford to have physical robot with him. So we have come up with robot simulation software, which is world's very famous product. Most of automotive manufacturing companies are using this product for designing their robot assembly line. We want to introduce the more detailed features of this product. Most of you are already aware about RoboDK, but now what new in RoboDK that we are going to explore? And very interesting part we have covered, that how do we integrate artificial intelligence with robot. With me, I have AI expert Mr. Vivek Salwaru, and Jitu also work on Python script integration with RoboDK, and somehow we could do it successfully run also. That part also we are going to cover at the end of the webinar. So this will be great advantage for you all. I'm sorry, I was not well for 2 days, but since this session was arranged, I thought not to miss your company. So Once again, I'm very thankful to you all that you have joined, and I would like to show you Industry 4.0 setup we have created in Vidya Pratishthan Kamal Nayan Bajaj Engineering and Institute of Technology. It is rural India's first Industry 4.0 Center of Excellence. I request you to kindly watch this with full attention, and after this, then we will come to know that how do we integrate software with hardware, and with this great orchestra, we can make sure that we understand this technology in better manner.
We are witnessing a phenomenal growth in manufacturing sector in our country. To cater to the ever-increasing needs in this sector, Vidya Pratishthan Baramati has established a Center of Excellence in Digital Manufacturing and Robotic Automation. This Center of Excellence has been established in line with the vision of Honorable Shri Sharad Chandraji Pawar Saheb and valuable guidance and support from Honorable Pratap Rao Pawar Saheb as well as all trustees of Vidya Pratishthan. This Center of Excellence is funded by Phenolix Cables Limited and Simisoft Technologies Pune is the implementation partner.
बारामती विद्या प्रतिष्ठानमध्ये साकारलं जातंय भारतातील पहिलं डिजिटल मॅन्युफॅक्चरिंग आणि रोबोटिक्स ऑटोमेशन यावरील सेंटर ऑफ एक्सलन्स. जवळजवळ ह्या पूर्ण 4000 स्क्वेअर फीटमध्ये आपण एक इंडस्ट्रीचं प्रतिरूप बनवलेलं आहे की जी इंडस्ट्री 4.0च्या तत्वावरती काम करते. इंडस्ट्री 4.0 म्हणजे आत्ताची जगातील चौथी औद्योगाची क्रांती, ज्यामध्ये तुम्हाला मानवविरहित उत्पादन कसं करता येईल, PLC, ऑटोमेशन, रोबोटिक्स, आर्टिफिशियल इंटेलिजन्स ह्या सगळ्या तंत्रज्ञानाद्वारे आपलं उत्पादन तयार करून ते जगाच्या तोडीस तोड पडेल अशा पद्धतीचं उत्पादन कसं करता येईल, विद्यार्थ्यांना याविषयी कसं अवगत करता येईल, विद्यार्थ्यांना या आधुनिक तंत्रज्ञानाबद्दल कुशल करून त्यांना या उद्योगांना कसं पुरवता येईल, यासाठी हा सर्व उपक्रम आपण करतोय. भारत हा युवकांचा देश समजला जातो, कारण 65% लोकसंख्या इथं युवकांची आहे. मग इथल्या युवकांना आपण जर तंत्रज्ञानानं सक्षम करू शकलो, त्यांच्या हाताला कुशल असं तंत्रज्ञानानं काम देऊ शकलो, तर मला असं वाटतं की जागतिक दर्जाचं महासत्ता होण्याचं स्वप्न आपलं खूप लवकर पूर्ण होऊ शकेल. या विद्यार्थ्यांना जर हे आधुनिक तंत्रज्ञान आपण दिलं तर त्या जागतिक स्पर्धेमध्ये ग्रामीण भागातील जी मुलं आहेत, मुली आहेत, त्यांना सुद्धा तितक्याच दर्जेदार दर्जाचं शिक्षण, कौशल्य या सेंटरमधनं आपण देऊ शकतो. आपण इथे आहे 6 ॲक्सिस मित्सुबिशी आर्टिक्युलेटेड इंडस्ट्रियल रोबोट. नंतर ही आहे स्मार्ट फॅक्टरी, ज्याच्यामध्ये सेन्सर्स, PLC, रोबोट या सर्वांचे इंटिग्रेशन करून ऑटोमेटेड पूर्ण फॅक्टरी आहे. नंतर इलेक्ट्रोन्यूमॅटिक हायड्रोलिक्स लॅब ही पुन्हा IIoT शी कनेक्ट आहे. IIoT HMI बेस्ड न्यूमॅटिक लॅब, IIoT HMI बेस्ड सेन्सर्स लॅब, अद्ययावत असं 3D प्रिंटिंग लॅब, CNC 4 ॲक्सिस VNC, IIoT HMI बेस्ड पूर्ण स्कारा रोबोट सेल आणि या सर्वांचं एक प्रतिरूप, या सर्वांना एक सिम्युलेशन मध्ये बांधलेली एक संगणकाची सिम्युलेशन लॅब. या सर्व इक्विपमेंटचं प्रतिरूप या सिम्युलेशन मध्ये असणार आहे. एखाद्याला रोबोट वरती काम करायचंय, CNC वरती काम करायचंय, तर तो पूर्ण त्याचा प्रयोग, त्याचं डिझाईन या सिम्युलेशन मध्ये तयार करून त्याचा आत्मविश्वास वाढू शकतो आणि नंतर त्यांनी केलेलं काम या हार्डवेअरती जाऊन स्वतः टेस्ट करू शकतो. इतक्या अत्याधुनिक पद्धतीचं, इतक्या जागतिक दर्जाचं सेंटर ऑफ एक्सलन्सचं स्वप्न या विद्या प्रतिष्ठान बारामतीच्या सर्व ट्रस्टींनी इथल्या विद्यार्थ्यांसाठी आणि इथल्या उद्योगांसाठी आपल्या समोर साकार केलं आहे.
So this is what we have done along with faculties of Vidya Pratishthan Kamal Nayan Bajaj Engineering Institute and Technology. For 1.5 years, we are getting phenomenal response from the students, nearby industries, and skill force. Now, taking this initiative ahead, we thought to share our some project work also. But before that, we want to win your confidence that with small investment also, a common students can understand the beauty of robot without investing huge cost in that. And it is proven that during the COVID incident, most of our education was blessed by simulation products. So, like simulation benefit, RoboDK is now a great blessing for all of us. We have more than 140 robots library available. OEMs like Kuka, Mitsubishi, Fanuc, Yaskawa, like entire plethora of robotic manufacturing companies are available. You can take any robot of your choice, get that, take the grippers, take any CAD design, and build your entire robotic assembly system. So you will feel as if you are walking through your factory. Once you are done with that, you will be able to win the confidence in you, and later on, once you are okay with this 80% work, rest of the 20% work you can actually get done on actual robot. Now to just tell you, I'll show you one example. Do you have that Cadbury example with you? Yes. I had been to Cadbury plant in Tathaude, and they had asked us that whether we can solve their physical problem. And in no time, we would be able to convince them with the help of robotic simulation. Now, the problem statement was shared by Cadbury was the mold. They had to check whether mold is cleared or not. So one person was dedicated for that particular work, and he was exposed to the running conveyor, which was not good from safety point of view. And then later, this problem was explained to us, and in no time, we could convince them that this is how, if you can develop this robotic assembly line, your work will be smooth way it can go. So what we have done, a camera vision system we imported, real Mitsubishi 6-axis Kara robot we imported, then the conveyor system we imported in RoboDK software, and we created that problem statement in actual real world. And with this, we'll be able to convince Cadbury people that if you can have this kind of a system, entire bill of material, entire cost, we can. So this is how we can really make the exact replica of your digital system or actual system in digital environment and get your work done. Now, if you can give such a kind of a problems to your students, and see, you don't need to buy anything, you don't need to buy any big complex robotic system, vision system, but at least for third year students, your fourth year students, you'll be able to clearly tell them that this is how phenomenal magic you can create in virtual environment. And believe me, this is not only an animation product, it is hardcore software used by companies like Bajaj, companies like Bharat Forge, companies like Pari, and people who are knowing this product, there is high chances that your students can be placed in a very good career options in manufacturing, automotive, at any corner where robots are used. So, with not taking further more time, I'll request my engineer to share you the exact screen of RoboDK product, and he will, along with your involvement, we will create some simulation models of existing problem using RoboDK, and at the end, we will talk on AI integration with RoboDK product. Thank you.
Thank you, sir. Now I will present the screen. So sir, the screen is visible to everyone.
No.
Hello.
screen are not visible.
Yes, it's
Yes, it
visible.
is visible. Okay. So basically, this is the interface for the RoboDK software. So now we will check the RoboDK library, online library here. Basically, RoboDK is a very powerful software which is have extensive libraries like brands like ABB, Kuka, Fanuc, Omron, Obo. So we can see here. So there is a question, right? Why RoboDK? RoboDK supports offline programming. What do you mean by offline programming? Offline programming means there is not a need of actual robot. We can do the simulation in the software and give the program directly to the and feed the program directly to the actual robot. So here you can see brands like ABB, Kuka, Fanuc, all are the needs type of robot access what you want, like 3 degree of freedom, 4 degree of freedom, 5 degree of freedom. Degree of freedom means in how many independent axes the robot can move. Suppose I need a robot that can move in independent 6 joints. So I the requirement for me it will be 6 degree of freedom, right? Am I audible?
Yes,
Yes,
you are.
sir.
Yes. So basically, simulation softwares are why we use simulation software. Basically, it is used to reduce risk, and at the same time, we will the cost required to buy a robot individually can cost high, right? So we can do the same simulation in the RoboDK software and feed it to the actual robot. So you can see, we will take a brand, we will take a Mitsubishi robot, 6 axis robot, Mitsubishi. So basically, this is the online library where you can find extensive robot library. Like, let us download a robot here. So we can directly go to the online library, offline library of our system and open the robot. Everyone are able to see the robot. Is the robot visible?
Yes.
Yes, sir.
So to by double clicking on the robot, the panel you can see here. Basically, this is the teach pendant of the robot, where we can control its axis individually in X, Y, Z, and the other three axes are roll, pitch, and yaw. Now I will require. I need a tool, right, to perform a operation. So there are various types of tool in our RoboDK software, like laser cutting, deburring, pencil tool, vacuum grippers, and various welding guns. Here you can see that e-grippers, magnetic grippers, vacuum grippers, generic paint sprayer. Okay. Does anyone have questions from till here? Any questions?
No.
Okay. So how RoboDK simplifies robot programming? Actually, there is no need of any hardware material required, and we can directly give the targets to the robot by moving the joints of the robot from the teach pendant. So now I will take a open my online library and download a small. We will add a table. Directly we will download it and open it from our tab. You can see the base of the robot is directly attached to the RoboDK robot. So you can see it is very simpler, right, to use RoboDK software, and we can add this software in our the curriculum for academics of from first to fourth year of students of engineering. Not only this, it will teach them manufacturing, research, and how the assembly line works in the industry in real time. So let us add a small cube or box to perform our. We will take a small pick and place application here. See, you can directly move the box from here from the teach pendant. Now there will be a question, right? How the by adding this star button from the keyboard, you can see the workspace of the robot. The workspace of the robot is the maximum range the robot can move or can work in the environment. So the this is the maximum reach for the robot. So now we will add a gripper to the robot. So again we will go to the online library and go to the type, uh, add to the tools. We will take a vacuum gripper. Simply download it and go to our offline library and add the gripper. So you can see the gripper is attached to the robot at the end effector. Now the end effector face should be at the parallel to the box. So you can directly see or change the joint angle. So the joint angle for the end effector is joint 5. So I will simply move it in the joint 5. Okay. Simply I will do it as 90. So you can see many industries uses RoboDK for automotive manufacturing and assembling of various parts, and not only assembly and manufacturing, we can also do 3D printing, and we can also integrate this robot with AI and do various projects, and it will be beneficial for students as well as it will be beneficial for them at the industries how it actually works. So till now, does anyone have any questions? Any questions till here? Am I audible?
Yes, you are audible.
Okay.
Yes, sir.
Okay, right. So now I will simply program a robot in such a manner it will pick the box from here and place it here. So you can directly add this by clicking Alt. You can directly move the robot in this direction. Before adding a target here, I will give the robot a safe point, which will help in the industry to give from the to reduce the risk of the failure or collision. So I will simply move it in the Z axis to give a safe point to the robot. This is the, you can rename it to in such a manner it will be organized. Safe point. Now we will add a pick point to the robot. Pick. Simply move in the Y direction. You can see here these frames. Y stands for green, X red, and blue for Z axis. So now I have to move the robot in Y direction to place it here. I will simply move it in the Y direction and add a drop safe point to the robot. Drop safe. We will give the name drop S. Now simply and the drop point. And we will add a home position for the robot. Now we have taught the robot the targets that the robot have to move. To give the movement, we need to program the robot in such program the robot, right? So we will add a program function and give it as name as pick and place. Now clicking on home position, you have just give the joint angles to the robot. So you can see here joint angle, linear movement and circular movement. So we will add joint movement. You can see in the robot tree in pick and place program the home position is added. Now pick point, no, save point, pick point, again to the save point, drop save point, drop point, drop save and back to the home. Now the robot will only move in a direction the the movement like save point, pick point, save point and drop point. We have to give the program a command. How to give the command to the robot? So you can simply right click on the pick position and add instruction and click on simulation event instruction to attach the and start the gripper and simply OK. Now we will simply do the drop point at same process simulation instruction detach. OK. So our basic pick and place program has been completed and we can simply run by clicking the program on the pick and place by double clicking it. Here you can adjust the speed of the robot by simply dragging Now let us run the program. So you can see the pick and place movement here, right? Now let me undo. Till here, does anyone have any questions?
What type of information we can extract through the simulation?
We can information in what ways? Can you reframe the sentence?
Information in term of for the publication part or for the some data.
Hello,
What data
what's
we
your
can
name, sir?
extract? Pankaj, Dr. Pankaj
Oh, okay, okay.
from GLA
So,
University.
yeah, so this is a product whereas you have to create the virtual replica of your robotic system. So, entire robot program you can get and you can give it to your publication. I mean the analogy. What I will tell you, you must be knowing CNC machine, right?
Yes,
Yeah. So in CNC machine, what do? You use CAM product and create the G code, M code automatically.
yes.
Now, similarly, if you want to build any robotic system, you immediately can't go on shop floor and start building it. Before that, you need to have simulation run. And once that happens, you can create that entire simulation code. You can put that code on actual robot and you can make your robot move according to that data. That entire code you can attach to your publication. That entire code you can actually dump on your robot controller and you can make the system move.
Okay, that's coding we can extract from this simulation.
Yes, yes. That is what the significance of this robot, no? Otherwise, once you are sure that your robotic system is working as per your expectation, then only you can get that data, get that code, and actually dump on your physical robot. That is what the beauty of this product.
Okay, extracted coding we can directly implement or directly put on the actual or physical robots.
Absolutely right. Absolutely right. We can now, once this coordinate system taught to the robot, now that entire robot program we will show you how to extract and then take it on actual robot system. Shall
Okay,
we go
by
ahead?
through this simulation, we can teach the robot, and according to the teaching program, we can extract the data and then load in the physical system.
Absolutely right. I mean, you can teach the robot, you can get the coordinates, you can, I mean, whatever you have idea in your mind, you can first of all get it done on your virtual environment, and later on, now for example, you have Mitsubishi, you have Kuka, so all that exact model, if you have the same model, you can put that on your physical robot.
Okay, more or less similar robot we can extract from the library.
Yes, we have that library that Jitu already have shown you what all OEM library we have in Robotics software. So it is
Okay,
not restricted to only one product. You have many OEM of robot, and accordingly you can create that simulation program, get that data, and put it on your system.
so we are completely dependent on the library, or we can individually we can create our own robotic arms.
Okay. I mean, we that situation has not come yet. We have not any robotic. We are not have faced such kind of a problem yet, because whatever the robot are available, that work is itself is not done yet. So we have Mitsubishi, Fano, Kuka. These all standard products are available. So that work we can initially start with working on that.
Okay.
Okay, we'll go ahead. I think good Pankaj sir, you have asked a very good question for all other viewers can also
Yeah,
know. That was
hello.
very important question. Yes, please.
Yeah, myself Kumar Vishnu. Actually, during the extraction, in which type of software code it will be provided? In which
Sir,
language, like you
could
are
you please
using particularly to the particularly any language.
repeat your sir? I could not get you properly.
Okay. The extraction will be in which type of language, in which type of coding language. Do you have any
Python script.
particular coding software or coding language
Python,
for that?
Python, sir. Python script.
Okay. Okay. So it will be generating automatically by using these coordinates, right?
Yes, sir.
Okay. Or is there any necessary of adding the codings into the tool here?
Sir,
Only
see,
you are going to provide the coordinates and how the robotic movements.
no, no, no. I mean, whatever you want to do it in your, as per your problem statement, as per
Yeah.
your research problem or your project problem, whatever assembly line you have, you first of all
Okay.
create the digital copy of that entire process sheet, get it
Okay.
done in RoboDK, and then accordingly teach robot. And then once you are done with that, then get that program and then put it to your system. This is the
Okay.
this is how in industry also they do similarly.
Okay, then
So
there
that
are no prerequisites for learning this tool or for this particular thing, right? To learn this
no sir,
robotics, there
it
is
is very
no,
easy product. Now see,
yeah,
even we are teaching it to art, science, commerce people also, and it is like drafting your rangoli.
yeah.
So all ready-made libraries are available, and you don't see what is the problem is only fear. Now, since it is virtually available, and you know that what library, where is the gripper, where is the assembly line, where all those components are in the library. Once you are known to that, then it is the rest of the thing. You just need to network the dots.
Okay, is there any free license for learning or for practicing this, or it must be something like a paid version only we need to take, something like that?
Sir, it is not free. Nothing is free in the life. So we'll have to pay for that if you want to learn something great.
Yeah.
So let's go ahead. Anything, anyone, any other question, please?
Can we use sensors?
Hello, sir.
Can we use sensor?
Yeah, I mean that code has to be imported into Python, and then you can get it done. As of now, we don't have PLC and sensor available in RoboDK.
Okay.
But camera vision, that sensor connectivity, if you have that ready-made coordinates, no, that we can go ahead on that.
Okay.
So there was a question, right? How to generate the program? So we can directly click the program here and
Hello. Yes.
generate program, right? Able to see the program here, generate program option. You can
Yes,
simply
yes.
generate the program and code will be in Python script. See, this is the code for this program that we have just simulated. Pankaj sir, are you able to see this code?
Yes, yes, we
Yes.
are able to see.
So this is the code for this program. We can directly feed it to the actual robot, and the robot will move in the same manner how it is working in the simulation. Okay.
Okay, nice.
So more questions. Is it
Yeah, we
possible
will
to?
issue. Is it possible to design our own grippers and use it?
It is very much possible. You can directly add the CAD file from and import it directly to the RoboDK. The type of gripper you want and the design you want, you can directly add it to the RoboDK, and you can customize it also.
Can able to connect with cross. Yes, yes, we can import that.
We can which can be able to connect. Yes, yes. RoboDK can be connected with ROS system directly. And what was the question? How to import the CAD file, right? So basically, you have to download it. Suppose here is the my interface, and you have to just import it directly from our offline library, the CAD file that you are required. Okay. Saddam,
कॅडची फाईल घे ना टेबल वगैरे ते इम्पोर्ट करून दाखव ना.
Saddam sir, are you now your question is been
तो सध्या नाही आपला त्याने उत्तर दिलंय.
okay.
I answered the Chandran sir question, not asking.
ओके ओके सध्या या.
Okay, okay. So now should we taught them the AI integration?
Yeah, I mean, first of all, Vivek, are you there?
Yeah, I'm there.
Okay, can you just explain? I mean, you don't have product with you, but at least can you just share your views that how AI can be integrated with robots? Before
Yes.
that, just give me a liberty to explain. I mean, can you just show me the ready-made models which we already have created in a just because we are now at the end of the session.
Ready-made models.
The kind of Cadbury model we had shown them.
Okay.
Similarly, other models if you have, can you just show them? वेगवेगळे प्रोडक्ट केले होते ना.
So basically, you can see the vast how this software is so powerful that you various applications like additive manufacturing, machining, material handling, conveying, assembly. These are all the models. You can directly download it and open it in the RoboDK software. I will give a try. So I have downloaded an assembly file. See how assembly works, and same program we can generate and feed it to the actual robot. I will reduce the speed. How assembly is working in RoboDK. So you can see this is the beauty of RoboDK, where we can do not only pick and place but also assembly, material handling, 3D printing, conveying, drilling. These are all the applications for RoboDK. Now, can Vivek sir, you can continue.
Okay, thanks, Jitu.
Okay.
Yeah, so Jitu has very crisply explained how RoboDK works and what application we can have in terms of industry level products. So yeah, so there are two things here, as he has already explained. One that is the simulator, and one is the actual robot, right? So it's very important that you get a very good knowledge of how to use the simulators, because there are certain actions which you cannot directly perform on the actual robot, because if there is a error in your program, and if it results in a very massive movements of the robot arms, then it can actually damage your robot, right? And these robots are really very costly. So simulator is always a very good playground for all of us who are new to RoboDK, or rather who are new to robotics, and getting a handle on RoboDK would be the first step, I would say. And after that, you can always go on to the actual robot and have a idea of how actual robot works, right? So this is what the background was set. Right now, yeah, so now we are in the AI world, right? So AI is like the new buzzword in the software industry, and everyone is trying his best to get into this area and do some innovative things, right? So what I would say is the brilliance of AI will get magnified or will get complemented when you are able to use AI with other modules. Like if you use AI with IoTs, then you have a different use case. If you use AI with robotics, that will be a more uh, uh, like a new use case in um, mechanical industry or any other industry where robotics are mainly used. Like even in healthcare, we see robotic surgeries being carried out and all those things. So AI will basically help us to increase the accuracy, efficiency kind of things with robots. So that's why it will be really very important that we understand how we can use AI in conjunction with robots, and and believe me that this will be a real good opportunity for all of us to get some good jobs. I mean, whoever is looking out for a job in IT industry or mechanical industry or any other industry. So this combination will really help a lot, right? Okay, so let's start with. I won't go much into detail of what AI is and those things, but we'll just look at a practical point of view how AI can help. So, as you know, that AI is mainly about data. Okay, so that data can be in any form. It can be an image, it can be a video, it can be a text, it can be numerical values, right? So AI has created different subdomains depending upon the data which you give as an input to AI. So now suppose I have to do say object detection or classification. So like given an image, and if you want to find out whether a particular object is present in that image, then AI helps you with certain AI algorithms, which we mainly call as the deep learning algorithms, the CNN based algorithms, right? So these algorithms are very much efficient, and if you can use it in the right manner, you will get the right output, right? So this is one case, the data which can be either images or videos. Another kind of data is which you very frequently we use chat gpt. You just put in some text and you get an output in kind of a very beautiful summary which helps you understand, or rather it gives you pointers, further pointers of what I want to explore, right? So NLP is one another form of AI which is very widely used, right? So these are two main things. Let's see how we can use this in robots. Now consider a case that a simple example, like as Jitu explained, how you configure a robot, you place it on a table and those objects, and you move those objects from here and there. So now this is more of a mechanical job, right? There is not much intelligence in that. Now consider a case that you have different types of fruits placed on a table. It's apple, mango, and whatnot. So and you want to instruct the robot that you pick up a particular fruit and put it in a basket, right? So here the intelligence comes. What that? Let's look at how the setup would look like. You have a robotic arm. In front of that robotic arm, you will attach a camera. That camera would be connected to some microcontroller, and that microcontroller would further instruct the robot to make the necessary movements, right? This is the flow. So the camera would like if you want to pick a particular say fruit like apple, so how does your program knows that what instruction I have to give to the robot so that it goes exactly to the apple fruit? So here the object detection comes into picture. So AI is basically consists of models, what we call as a models. Like my program should know how an apple looks like, right? So first of all, I would create a model out of the apple object, like the apple, how the apple looks from different angles, what can be the different shades of the apple, and all those things, right? So considering all these different types of images, you would create a apple AI model, right? So through the camera, you will scan those. It's like the camera is doing a real time capture of the images, every image it captures, it will try to apply the AI model onto that image and try to find out whether it is an apple. Okay. Once it finds that it's an apple, it will give the further instructions, like the instructions which we saw here. Like Jitu was performing those drop and those operations, right? So all those operations in background would be executing or running certain commands on the robot, and which would be further causing the arms to move, right? So this entire flow, you are just putting a AI intelligence in between, which will take some intelligent actions or intelligent decisions to find out whether I have to pick an apple or whether I have to pick a mango, and then take the next action. So just to summarize, what additionally we are doing here is we are putting an AI module in between, which has a sensor connected to it, that is a camera. It will capture those images, do some analysis on those images, and further instruct the robot to take the necessary action. So is this clear? A very simple use case, but it will give us an idea how AI can be used. Any questions as of now? Okay.
Is this integrated into your software in any way?
No, we are in process of doing that. We are actually trying to, like, now everyone is who wants to learn sorry, everyone who wants to learn RoboDK should first get familiar with how Python programming is done. Okay, so that's the first step, and the next step would be how I can include my AI related code in my Python, right? So these are like stepwise we have to go, and then we will be able to, yeah.
Jitu has created one program. So
Okay.
Shall we show them?
Yeah, sure. Yes.
Yeah, madam. Hello.
Yeah.
Hello. Yeah. Will you allow me to show you one program, that Python script we already have imported in RoboDK, that will try to detect the object, and accordingly that arm will move towards that object.
Yeah, surely.
Yeah.
Okay, let me show you. So by simply taking a robot from my offline library, suppose I'm taking a VR10 robot, adding a camera to it. Now I will import my Python script.
Just explain where is the camera you have added.
So you can see the camera is attached to the instructor. Attached to the camera, you can see the camera.
Yes.
Yes.
Okay. So camera we already have imported. Robot we imported. Now Python script that is already created, that will try to coordinate with robot and camera.
So I will simply run the Python script in my RoboDK.
Python, show the script first.
Okay. So this is my Python script.
And ma'am, this you can also get it on ChatGPT, or I mean, it is readily available. How do you integrate with Azure? Now technology has evolved so much that we just need to reap the benefit out of it, and you should have some, ready-made tools with you. So once you are there, I mean, in no time we can enjoy any applications of your robots and AI. So this we already have taken from ChatGPT, isn't it?
Yes, sir.
And now we want to win your confidence that how seamlessly it can integrate with the RoboDK.
So first of all, I need to off my camera. So you can see my screen, right?
Yes.
Okay. So should we run the program, sir?
Yeah.
Okay. By simply double clicking on the program, Are you able to see? My robot is moving in such a manner how I am moving.
Can you see the screen?
Yes, yes, it's visible, but
Now,
it's just getting struck a bit.
Yeah.
yeah, now the point is what, as Vivek sir has rightly mentioned, now it is detecting the face of Jitu, and according to that face movement, that robotic arm will move its position.
You can see. You can see the movement here, right?
Now I will I will change my movement to let me come into the frame. Little bit slower. Yeah, I'll come to the now the existing laptop camera, that computer camera now it has taken into consideration the virtual camera on RoboDK, that is also aligned with. And now I will move accordingly. That robot arm will move.
It's lagging.
It is little bit lagging, but it is moving. So this way you can integrate with your Python script of whatever AI script you have. You can get into RoboDK and check whether it is going to work or not. And once you are 100% sure, then you can come into the main party. Vivek, am I right?
Exactly.
Yeah, please take it ahead now.
Yeah, so very nice demo which Jitu has presented. So it gives you idea of how to integrate camera with the actual RoboDK simulator. You don't need any hardware as of now, right? You're working everything on a simulation software. Now,
Yes.
this was one of the use cases where we have to do object detection and classification. Classification means what type of object, whether it is a cat or a dog, man or a woman or something like that. So that is first use case. Second use case is NLP. Now, NLP is something called as a natural language processing. Now, I should be in a position to instruct the robot by speech. Now, if I say, hey, RoboDK, pick up an apple, right? So this text, this speech would get converted into a text, and that text would be further processed by the RoboDK, and it would do the necessary action, right? So here then another flavor of AI, which is the natural language processing, comes into picture, where you are instructing the robot using some human language, right? So this is another thing which is very useful, which can be used in future wherever there is an instructor who wants to perform some job depending upon his instructions, right? This is NLP. Now, one more interesting thing in AI is something called as a reinforcement learning. This is a bit complicated, but I just wanted to mention it here so that you understand its importance. Now, let's get on to a different topic to understand this in a better way. That is the reinforcement learning. Have you guys heard about Alpha Zero computer? Yeah. So what this Alpha Zero is, it's a AI model which learns chess moves of its own. Okay, and it has defeated. Uh, I don't know the name of the person, but one of the Grand Slam chess champion. He has defeated this person, right? So how this Alpha Zero worked actually? It worked using reinforcement learning. What this means is, whenever I make a move, if that is right, either it can happen that it is right or it is wrong. If it is right, then we assign some positive rewards, or I would say I assign some rewards to that model. So when it gets a reward, it knows that yes, I have done something good. Now if the next move is something which is wrong, then I reduce its rewards. Like if initially the reward points were given 5, then if I give -5, then I come back to 0. So by this method, the model learns that if I do this, it's going to be good. If I do this, it's going to be wrong. That's why it is called as a reinforcement learning. Okay. Now, how can I use this in this RoboDK thing? Now, in our case, what we were doing right now is we were giving the exact coordinates of the apple, right? Earlier to pick up for the robotic arm to pick up. Now I'm not going to reprogram myself. Okay. Whenever my program runs, it is its responsibility to pick up the red apple from the right position without giving any locations. So here the reinforcement learning comes into picture. Now how this works basically is, we know very well that any AI model has to be first trained, and then we put it in a deployment where actual the AI thing works. Similarly here we have something called as a reinforcement training. By training, what we mean is, what we do is to the simulator, we call for certain reinforcement learning algorithms. What it will do is, I will pass a parameter to it saying 50,000. By 50,000, what I mean is, it will do 50,000 operations using that robotic arm, during which it will learn from those 50,000 steps that what is the best step for me to go near a particular object. Right? You are not giving any coordinates. It just learns. What it will do is, it will move our arm in one direction and it will see whether I'm seeing the apple. No. Then again it will adjust itself. Whether I'm seeing it. No. So by all these operations, at the end of these operations, it will learn from this trial and error that what is the best way to identify an object. Right? So during the training, this reinforcement learning will help my SCARA simulator to understand how to reach towards a particular object. Right? So once training is done, I will deploy this RL model into my Python script. And when I do a real-time running of this particular AI model, it will take decision of its own. See how good this way is to learn something. Right? So this is one of the ways the AI can help us do object detection, that is the reinforcement learning. Yeah, so I wanted to highlight these three basic AI related things which can be used in simulation software. And you can, as Sunil said, like ChatGPT is your best friend. You can have n number of queries and n number of things you can put on that, and you can get at least the pointers. I won't say you blindly believe in what ChatGPT says, because ChatGPT itself says that it can make mistakes, right? My point is, you use those the output given by ChatGPT, put your intelligence, put your thought into it, right? And then come up with more refined uh, code for simulation.
Best, right? Thank you, Vivek.
Yeah.
This is what actually I was expecting, because uh, ChatGPT AI um, is really a blessing for all of us. And then how do we use it? That going to decide the career of our next generation, and how we are going to adopt this in technology teaching. So it is great thing that all faculties, if they can really take the best out of this, it will be very easy for them in the classroom or in the laboratory also. Now, my dear faculty members, if you see, we have not touched to any robot, but till the date we have used, camera of our laptop, virtual library of all the robots, Python script. Then, if you don't have any code with you, you can download the code from ChatGPT, use it. I mean, whatever your practice you want to carry, all your permutations, combinations, virtual system will allow you to process it. And once you are done with this, then you can go to your research guide, or students can come to their faculties and get it checked, and then understand the entire ecosystems of robots. So I think anyone has questions on sessions till the time what we have covered.
And one last point, Sunil, what I would like to add is now I've been in
Please.
software for 25 years now, right? So I
Yeah.
know what the software trend is and what is going which way. So AI is going to stay for the next, say, 20 years. Okay,
Yes.
it's
Yes.
going to stay, and AI alone cannot survive. So
Yes.
AI has to be used with either, as we discussed earlier, either you have IoT or you have robots. All these use cases are going to be very, very strong in future. So it's always good that you pick up a use case of your choice and just start working on those. So robot is very good option, I think, uh, considering all the use cases and all the practical requirements in the industry. So I would definitely advise everyone to get this AI robotic combination into your career as soon as possible. Yeah, thanks.
Yeah, because I keep on meeting many. Now Sirkan sir is there. He's from mechanical department, and uh, when we talk computer engineering people, they says robot is not our cake. But in entire manufacturing industry or shop floor, we see now robots are used to clean the house, robots are used in kitchen, and they are mainly programmed by AI experts, those who all are from computer domain. So if robot is a device from mechanical engineering, AI is from computer engineering. So if they can come together, they can really make good out of this technology. So for them now, they can take the benefit of robot by using RoboDK, boost their integration capability, and similarly, mechanical people can learn AI programming and they can integrate their own robotic system. So nowadays, entire engineering communities has become one, and there is no any special existence for any separate engineering stream. So all mechanical, electrical, electronics, all put together now they have to work as a one team and see the integrated benefit of this entire robotic system. So now we will end up this session. Those who wants to know in much detail, they can communicate with Simusoft Technology. We are building entire robotic laboratory. We can say 6 axis, 7 axis, 4 axis, entire robotic assembly unit we can make for you. We can also give you robotic simulation software, which will, and with use cases like AI, IoT integration, and with this in low cost automation, we'll be able to train our youth on this newest technology. Do you have any questions till now? Should we take this session to end?
No questions from my side. I had asked about AI and I got
Okay, any feedback, Namrata madam?
from this demonstration, actually, we could get that how exactly we can incorporate both AI with the robot. So that is something which I'm looking forward to incorporate in my curriculum.
Where are you from, ma'am?
I'm from Nagpur. I'm from Saint Vincent Pallotti College.
Paluti College.
Yeah.
Okay, okay, yeah, I know that. I was in NIT Nagpur to set up some laboratory with Shital Chadravar madam
Okay.
in automation. Yeah.
Fine.
Anyone else want to express their feedback, please? Yogesh Kamble sir, Shrikant Madik sir.
Yeah. Hello, sir.
Yes, please, sir.
Yeah, so this was actually I'm using RoboDK for our SY students from AIDS Computer IT branch. This is the most needed tool as far as NEP structure is concerned, as we are going for multidisciplinary courses. So we have got the feedback from the students, and now they are now really means interested in these softwares. Now they have planned that they are going to done one mini project on this also. This is the extra things actually we are taking in our curriculum as far as double minors, honors, and multidisciplinary courses are concerned.
Great example that
So
NEP
thank you to
guidelines.
Semisoft Kaure sir.
Good, 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 good. Anyone else wants to express, please? Yes.
Yes.
Hello,
Hello,
everyone. Yeah, here you go. Hello everyone. We can share one feedback form link on our WhatsApp group. Please fill the feedback form kindly. Certificate. Okay. Thank you. So thank you faculty members, and we also request you to come to our Center of Excellence. It is in Baramati, and there you can see the live entire 4,000 square feet industry 4.0 setup, and we'll be in touch. Thank you. Thank you very much.
What about the certification? Hello?
Yes.
What about the certification?
Hello.
Yeah, what about the certification?
Certificates are not available, sir. We can give.
I think it's
Yeah,
available.
those who are filling the feedback, we will Swapnil has just confirmed we'll be giving certificates.